So in the previous session, we have got a better understanding of the text corpus through exploratory data analysis, right? So we have saw the frequency or the distribution of each and every word within the text corpus, how each and every word is related in a text corpus. So all these things are actually the exploratory data analysis refers to. So we have got a better understanding. We have better control over the data set. Now we are reaching out the final step of the agenda or objective of this hands-on session. So let's just look back at what was our agenda when we started this hands-on session. So So here it is, right? Since I mentioned, we will be dividing these sessions into three, exercise into three different parts. So the very first was reading and understanding the tagged data sets. Tick, yeah, we have done that. Then we have to explore and analyze different aspects of the text corpus. Yes, exploratory data analysis, done. Now what we left with is building of a model, an actual real-time model which does the activity of POS tagging, right? So our intention was to build a model to tag the word with appropriate POS tag, right? So for any NLTK task, when it comes to POS tagging, we generally don't jump on to the text and we start actually hand tagging each and every word. So that would be the crudest approach, and it would be taking very long time, right? So it should be better way where we can have a certain model which can do this for us, right? So if we pass a word or a sentence, I should be getting an output with particular POS tag for each and every word. So like when we build an advanced NLTK application or any text classification, chatbot building, all these things, so this POS tagging plays a very important role, right? So when we build a chatbot, especially when it comes to that, so when we try to make the machine understand the sentence or what the user has queried for the chatbot, it is very much important for the chatbot building to make that sentence tagged with the POS tag, to make that sentence better understand to the machine. So for that, we are going to build a simple model with two different approaches, that is a lexicon based approach and a rule based approach, and try to see how each and every model will perform and evaluate respectively. Like these two steps are completed. Now it's time to build the model. So I am going to build a very basic and very first POS tagging model that is based on lexicon based approach, right? So what for that, what we will do, since we have only one data set, right, that is this text corpus, that is a tree bank data set which we have downloaded from NLTK. So I'm going to use a test and train split, which is readily available within the sklearn. So if you try to remember over here, that so we have imported this particular method from sklearn.model selection. So it's time to use this method to split the data set into test and train. So we generally use this in any kind of machine learning task. We will try to do that over here. First we have to initialize some random number. So random dot seed 1 2 3 4, we can give it an any number, random number. So it is to make sure that data set which we have, the text corpus which we have, should be unbiased, or it should be properly shuffled to make that test and train data set split properly and unbiased way, in an unbiased way. So that's why we are using this random seed. So what I am going to do, so I am going to take two variables, that is a train set and a test set. So then I'm going to call this method train underscore test underscore split. So you can just hover this and you can just see that split arrays or matrices into random train and test subsets. So this is what it is going to do, right? So for that it accept two variables, that is one which is the main data set, the data set we are targeting to split. So that is the text corpus which we have defined at the earlier stage. Corpus comma test size equals to 0.3. So we can in machine learning task, when it comes to splitting of a data set into training and set, we can have a two different approach. We can either split the data set into 80 and 20 or 70 and 30. So generally I prefer to go with 80 or 20 or 70 or 30. So it completely depends on size of the data set as well. So we have to keep that in mind as well. So here I am going to split the data set into test as a 70%, sorry, test as 30% and training set as 70%. So that's what I am going to do with this particular step over here. So this step will do that for me. So I am readily available with 70% of the data, random data also. We should mention that. So random data available in the test, sorry, trained data set, and remaining 30% of the data available in the test data set. So we can have a just look at that as well. So print length of trained data set and printing. So I am trying to print the length of each and everything. So you could just see that. So our initial data set, if you have a look at it, so yeah, what was the size of that when we had a text corpus? Yeah, this was the text corpus, right? So this is the entire data set. So now we have split that into two fractions, right? So you can just see that the 70% of the data, that is 2739 entries or elements, are treated as a training data set, and rest 30%, that is 1175, would be the training sorry, test data set. So we can also have a look at a few elements which are present in the training data set. So to also make sure that data is well shuffled. So I could just see that, so it is already investor, noun, trading, some randomly picked words along with the POS tag associated with it. So now we have seen that our data set is readily split into training and test data set. And now it's time to build a very basic model POS tagger based on the lexicon based approach. So if you try to recall the lexicon based approach or lexicon based POS tagger, what it will do, it will try to associate a POS tag for a given word based on the highest frequency occurred POS tag, right? So in other words, it will take a word, say cat. So it will try to associate a POS tag to that word cat as noun or any other POS tag based on the frequency of that cat, how many times that cat is actually tagged with a particular POS tag. So if it is highly or most number of the times, if the cat is tagged with noun, then every next time when the model or the POS tagger encounters the word tag, it will try to tag that word cat with noun. So this is what a lexicon based POS tagger will do. So that's what we are trying to do now. So for that POS tagger or that model, what we can do, I have named it as a unigram tagger because it will be going to tag each and every word, right? So a gram refers to a term, right? Unigram refers to a single term. So unigram tagger equals to NLTK dot unigram tagger. So this is a inbuilt what we call model present within the NLTK. So for that model we have to train, right? So it is an empty model as of now. So when we feed this training data set, it will try to understand what it will do. It will try to understand the pattern, or it will try to understand the tags associated with each and every term, and it will try to learn those things when we do this step particularly. So when we pass the training data set, now our model is ready with the training data set. Now what it has seen is a training data set, right? But what the model didn't see or very unknown of would be this test data set. So that's why we generally split the data into training and set. So after training, we want certain amount of data to test, right? So to check whether the model has trained very well, how well or how exactly the performance of the uh, particular tagger is. So all those things can be analyzed by using this train and test split method. So when I try to pass the train dataset, it will learn the certain aspects. Now it's when it is done, it's time to evaluate. So unigram tagger, now it's not just a variable, but it's a model as of now, right? So it is a model. Now this model is trained with the trained dataset. Now when I call this function evaluate, like unigram tagger dot evaluate, it will try to analyze the freshly given data or the test data set. So now let's run this and we'll have a look how well that training or test dataset, or how well this lexicon based POS tagger is performing. So you could clearly see that it has done pretty well. Like it is giving us a result of 87.48%. Even though the approach the lexicon based tagger follows, that is it try to assign the like most frequent word, all those things, but it has done a fairly good job already, right? So it has yielded accuracy of 87.48%. So for any basic, just like uh, not very like complicated NLP task, but very basic NLP tasks such as text classification, say spam ham, say, so we can use this unigram tagger or lexicon based tagger to POS tag each and every word. So we can confidently say, like we have a good accuracy already, so 87.4, we can use this lexicon based approach. But this would be not sufficient when we come to build an NLP application which generally deals with the understanding of the sentences, right? So then we have to build a certain tagger that is more advanced or yielding a better accuracy than the lexicon based approach. So for that, we are going to build another POS tagger based on the second approach, that is a rule based POS tagger, right? So what does this rule based tagger? So I already mentioned in the previous theoretical section that we will be defining certain set of rules and we will make the tagger understand to tag that in similar fashion. So and also I have mentioned like what those rules would be generally looking like. So the generally those rules will be like so you tag the word which ends with ing as vbg. So this is how a rule look like, right? So whenever you encounter a word ending with ing, you blindly tag that word with ing. That's it. Okay, so that's what we are going to do in this step. So within that rule based approach, we have another sophisticated method, right? So while defining the rules, we can either define the rules like as I mentioned, like whichever the word ends with ing, all those things, but we can also implement regular expressions in this, right? So we can use a regular expression to define the rules more generic way. Instead of defining each and every rule, we can have a certain generic abbreviations or general rules to define to build this rule based approach. Regex are the like I will have a in-depth session on regular expressions in the further steps. But as of now, we can understand that regex are certain rule-based or certain things which actually perform certain action based on a given certain expression. So this is a overview or a generic way of defining the regular expressions. So since now we have given an overview or how exactly a rule based approach will look like. So you could just see over here. So generally a regular expression will be looking in this fashion. So it will be consisting of a term called R, that we are referring it as a regular expression, followed by single quotes, and this is an expression. This is an expression. So what I mentioned. So I am defining the very first rule, right? So this rules here you could clearly see that. So okay, now model, you just understand that whenever you encounter a word anywhere, like anywhere, starting from anywhere, ending with ing, that's what this particular rule seems to be like, right? So this is how a regular expression seems to be. So starting with any set of letters, if it is ending with ing, you just tag that word with vbg. Similarly, we have another rule, that is whenever you encounter a word which is ending with ed, you tag that word with vbd. Similarly, I have defined like most of the rules with the same like understanding. And for most of the numbers, say if it is like a number from 0 to 9 or any other numbers present in the text corpus, if it is the case, then you just tag that with a tag called as cd, that is cardinal numbers. Okay, so I think we have defined pretty much a very good rules over here. We can have a look when you practice that with yourself with the hands on. So you can just overview on this as well as of now. So now we have defined the set of rules. Now we have to like train that model, right? So we have to pass the these rules for the certain model to follow these rules and tag the given data set. So for that, what I am going to do, I'm going to run this particular thing. So regex, so this is what the model name which I have taken. So from NLTK, I have taken this tagger, that is regular expression tagger. So just like a unigram tagger, I have taken this regular expression tagger because I have defined this regular expressions and rules over here, right? So I have defined that model. Now the model is ready, and it is ready with the patterns. So I have passed with the patterns already. These are the patterns, that is the rules which we can say. I have defined it as patterns. We can define it as rules as well. So rules, I am going to pass these rules and make that tagger understand. See dude, these are the rules which I am going to explain you, and you have to tag the given set of words with by following these rules. So what I am going to do, I have done that over here already. Now it's time to check that performance of that particular tagger, right? So I just run this. You could clearly see that it is not so performing very well, right? So it has just what it is trying to do in the given test data set. It will just try to tag these words, like the words ending with ing, ed, with vbg, vbd, everything. But it has not. It has just followed the rules, right? It didn't understand any other set of words. Like there are other set of words which have which might not be ending with ing, ed, es, od. Like we have just defined a limited set of rules, right? So there are other set of words which do not end with ing, ed, etc. So what we can do, when I try to explain this rule based approach or rule based POS tagger, I have mentioned that this rule based POS tagger is a approach where we first apply this lexicon based tagger, then we try to apply certain rules on top of this, right? So it is basically built on top of lexicon based tagger. So but we have already built a lexicon based tagger, and we have also built a rule based tagger. But this rule based tagger is not yet completed, right? It is not complete yet. It is completed only when we apply this rule based tagger on top of lexicon based tagger, right? So that's what we are going to do in this final step. So this combining of taggers. So uh, I will just read out this to brief out what we have done so far. So let's now, by combining the tagger created above, we saw that the rule-based tagger by itself is very quite ineffective, since we have written only a handful number of rules, right? So we have defined very limited number of rules. However, if we could combine the lexicon and rule-based tagger, we can potentially create a tagger which is much better than the individual ones. So I am damn sure that this rule based tagger will outperform lexicon based tagger, because we are already taking this lexicon based tagger, and on top of that we are applying this rule based tagger. So it should perform, on a general assumption, it should perform better than this, right? Lexicon uh, approach, like lexicon based tagger, and also it should perform better than the current situation, right? Just by defining the rules, it is not performing very well, right? So it should outperform this as well. So that's why we are trying to combine these two taggers, this rule based and the lexicon. In other ways, I am trying to integrate this rule based on top of lexicon. That's what I am trying to do over here, right? So for that, the NLTK provides a very convenient way to combine the taggers. So we have a method called backup argument, so which will try to combine the two different POS tagger. So now we'll do that in this step. Okay, so here you could see a rule based tagger, that is NLTK dot regular expression, that is we have defined this rule based tagger, like we have taken this rule based tagger first, then lexicon based tagger, that is NLTK dot unigram tagger. But here is a twist. See, in the unigram tagger, what we did, when I am defining a unigram tagger or a lexicon based tagger, I have just passed the training data set, right, as of now. But here you could see, additional to that, I am giving a another term, right? Like I have mentioned, there is a backup option, right? So this backup will integrate, or it will expect another type of tagger, POS tagger. So for that, what I am going to do, I have defined this backup equals to rule based tagger. So I am going to pass this rule based tagger to this backup element, so that it will combine this unigram tagger with this rule based tagger. So it will do it internally. So it will try to, what it will do, so first it will take the training data set, it will try to tag each and every word completely by a lexicon based approach. Then it will try to apply this rule based tagger internally for all the words again. So it will like check each and every word, and if it is the word which is already following the rule, then it leaves it. If it is the word which is not following the rule, then it will try to change it, or it will modify the tag. So basically it will just say, now it is checking each and every word which is already unigram tag or lexicon based tag. Now it approaches a word, say like dancing. So if it has approached a word dancing, it should be generally tagged with the POS tag, that is VBG, right? So that's what we defined, right? So if it is the case, then it will leave that as it is. But suppose if that word dancing is tagged with any other word, say it is tagged with VBD or any other noun, then what it will do, this rule based tagger at the second iteration, it will try to change or remove or chop off that tag which is already tagged, and it will try to tag this VBG according to the rule. So I have just given an example over here. So that's what it will try to do in this step. So now we are ready with this training data set. Now it's time to evaluate on, or evaluate the performance of this combined or hybrid tagger, that is a rule based tagger, which is built on top of lexicon tagger. We'll try to evaluate the performance of it. Yes, you could clearly see that it is giving it the highest accuracy than both of the individual accuracies. The lexicon alone is giving 87%, the rule based alone giving 21%, but A proper rule based, which is built on top of lexicon based approach, is giving us a 90.57%. So by this we can conclude that this rule based POS tagger, which is built on top of lexicon based POS tagger, gives a better result in the task of tagging a given word or entire sentence with a associated POS tag.